Today we're going to work on scatter plots and lines of best fit. So really what a scatter plot is, it's points plotting actual data, where a linear function will be changing. Every point is going at a constant rate of change. In a scatter plot, we're looking at real data. Oftentimes the data will have a relationship where it trends in the positive direction or trends in the negative direction in a general uphill or downhill. Sometimes there will be no correlation, no relationship, and it's just a bunch of dots all over the page. So what we're going to start with is we're going to graph this data, and then we're going to look and see if it has a trend, and then we're going to come up with an equation of a line that would go in the general direction of the trend, really cut it pretty much down the middle of all your points. So what we're going to start with is taking the table in number 1, and we're going to graph it on the graph. So to start with, I want you to label your y-axis. So we're going to label the y-axis. We're going to go by threes. So we're going to start at the bottom corner is 0, and then 3, 6, 9, 12, 15, 18, and 21. And on the bottom, we're going to go by ones. So I want you to number your graph, pause your video, get it numbered, and then go ahead and plot all of the points in the data before you turn your video back on. So go ahead and get that plotted, and then turn the video back on, and we'll continue. Okay, so we've completed requirement A, which was making a scatter plot of the data, which was just plotting our points. Now we're going to figure out the correlation. So there's a couple of ways to think about correlation. We've got positive, negative, and no correlation. One way we can figure out correlation is to look at our data. If our data is going in the same direction, so my x values are going up, but my y values, they're not getting bigger. My y values are actually going down. So my data is traveling in opposite directions. If they're traveling in opposite directions, then it's a negative correlation. If it would be a positive correlation, they would both be traveling either up or they would both be traveling down. Kind of like a positive relationship, they like to walk together the same way. A negative relationship, they go opposite directions. The other option would be no correlation, and in no correlation, the data, some of it goes up, some of it goes down. There's just no relationship that you can truly define. So that's one way to look at correlation. The other way is to look at your actual graph. Easiest way to think about that maybe is using Mr. Slope Guy. And Mr. Slope Guy, I'm just going to draw him here. We got a positive and we got a negative. So uphill is positive, downhill is negative. We got his nose. If it's a vertical line, it's undefined. And if it's a horizontal line, it's a zero slope. That's Mr. Slope Guy. He's not the prettiest I've ever drawn, but that's him. That can help you know. So we've got a downhill or a negative slope. So this is a negative correlation. So let's go ahead and just circle that. Okay, the next thing we need to do is draw a trend line. So what a trend line is, it's something that we're going to use to predict. So to draw our trend line, we are trying to pretty much draw a line that goes through our points. It has to be a perfectly straight line. You can't go, ooh, connect the dots like in a coloring book, because that's not a trend line. A trend line is going to be a linear, straight line that pretty much goes through the middle of your data, going the same direction, same trend as your data. So some of your points will be a little above the line, some of the points will be a little below the line, but all the points are going to be as close to the line as you can make your line. So trend lines are kind of an art. So if I'm going to draw a trend line on this, I want everybody to pause your video, and I want you to try and draw your own trend line as best you can. And then once you've drawn your trend line, check back and see how mine looks, and we'll continue the discussion. So in looking at the trend line that I drew, you can see that some of the points are above. Actually, only one point is directly on the line, and some are below. I've tried to get a line that goes pretty much right through the middle of my data, splitting it as closely as I can. Now, I can use this line to make predictions about the data. The next thing that we're going to do is we are going to use our calculator to get what's called a regression, a line of best fit using the calculator. So we're going to get an exact equation for the very best line that fits this data. So the way that we're going to do this, and I'm going to write the instructions over here, is on your calculator, you're going to press the Stat button. The Stat button is on the same line as your green alpha key. You're going to press Stat, and then you're going to press the number 1, which is Edit. And you'll see on there that your L1, that's your X data, and your L2 is your Y data. So go ahead, and I want you to enter all of this. I want you to press Stat and Edit on your calculator, enter the X data from the table in L1, the Y data in the table in L2. Pause your video to get all of that done, and then turn the video back on for the next steps. Okay, so now that you've got all the data entered into the Stat Edit, you're going to go again and press the Stat key. And this time you're going to scroll over one, so you're going to press the arrow key over one to the word Calculate, or Calc. And that's going to bring up the Calc menu, and we are looking for a line of best fit. So notice we're looking for lines, so that's linear. So you're going to press 4, which is linear regression. So it's going to give us the line of best fit. Once you've pressed 4, you're going to press Enter all the way through the screen until you get to the word Calculate, and then you're going to press Enter again. And that's going to give you the information for your line. It's going to give you y equals ax plus b, and then it's going to give you the value to plug in for a and the value to plug in for b. So go ahead and do that and write the a value is going to be your slope. You're going to put it here. The b value is your intercept, and then write your equation rounding it to the hundredths. Pause your video to do all that and then check back for the answer. Okay, so if you rounded off your equation, then this is about exactly what you would have gotten. If you look at your graph, you'll notice that the y-intercept is somewhere between the 18 and the 21, depending on how you drew your line of best fit. So our y-intercept makes sense. Our equation makes sense. So now we just need to interpret, what is the slope? What does this mean in our situation? And what does this mean in our situation? Well, the slope means that our sales are decreasing, negative. They're going down by almost $2 million every week. And in our situation, this y-intercept has no meaning because there's no sales in week 0. So it's just kind of where we went back to get to the y-axis. So this has no meaning in our current situation. Okay, to find the correlation coefficient, we're going to have to go back to our calculator and we're going to have to turn on our diagnostics. So to do that, we're going to press second, that's the blue second key, and 0. Well, 0 is the catalog key. And you're going to scroll down to Diagnostics On. And you're going to press Enter twice. So Enter, Enter. And what that's going to do is you're going to then go back and you're going to do this whole process one more time. And when you do this process one more time, when you get all the way to the screen with the A value and the B value, there's also going to be now an R value with a whole bunch of decimals. So go ahead and turn on your diagnostics. Go ahead and do the Stat Calc 4 again. and write down what the R value is. Not the R squared, but the R value. So go ahead and do that. Pause your video while you do it, and then check back for the last discussion. Okay, so I came up with a correlation coefficient, or an R value, of negative 0.98. So let's talk about how the correlation coefficient, what it means. And really what it is it's a scale from -1 all the way to +1. So your R value is going to be anywhere from -1 to +1. And the way it works is on the scale, the closer you get to either -1 or +1, the stronger your correlation is. When you get all the way to -1, you are at a straight line, a complete linear equation. When you get to +1, you're also at a complete linear equation. It's just a positive line instead of a -1. When you get to 0, there is absolutely no correlation. So the closer your number is to either -1 or +1, the stronger the correlation. So when we look, we've got negative 0.98. So we have what's considered a strong, because it's very close, negative, close to the -1, correlation. And that's all the correlation coefficient tells us. And that makes sense because when we look back at our picture, we've got almost a straight line. All my dots are very, very close to my line.